And I will pop this window out so I can also see, oh, I can see all the wonderful messages since then. Somebody making their bed or rolling a cat up in a, I don't know what's going on there. Oh, Dachshund, wonderful. Hello, a fish. Let's see, everybody. It was a weekend. Excellent, excellent. All right. So good to have you all here. Thank you so much. One thing I wanted to mention, it looks like not quite everybody yet has an account on Perforce, but a lot of people do, and some people have been successful in setting up, which means that the video tutorial that I have can't be all that bad, because so far the people who've kind of gone through it, spot on, looks really good. The key things is that our server is has-helix.win.rpi.edu:1666, no spaces in there, that's important to know. You're going to be using your RPI, your RCS ID, your account name, and then when it asks you for a password, that is your RPI password, because this is an RPI hosted service. When it asks you for the workspace, or you're prompted, you can create a workspace, you can call it whatever you like. However, it has been noticed, I had assumed that this was something that was unique per user, but it turns out that it has to be unique per server. So that's one reason it typically, if you see the default name for something, it goes ahead. You did the term, okay. Let me finish, okay? So your workforce, normally when you create a workspace, it's going to put your like computer name or your username, which is totally fine. The workspace is really something that's just for you, right? So it's the mapping between the server and your local machine, right? So you can call it whatever you like. I recommend having IGP in the name, but you could really put anything in there. Putting your RIN in there, or your not RIN, your RCS ID is a good way of making sure that's unique, because your RCS ID is unique. I see a question about, I did the tutorial but didn't make the Unity project. Is my setup still fine? Well, it's hard for me to say, because until you actually put a Unity project in the depot, I really can't see any change, right? You may have signed in and downloaded and created your workspace and so on, but I won't see any changes. I won't see any files uploaded. It's really the moment you start submitting files to the depot, then I can see that activity, right? So I see that starting to happen. So make sure as you're going through things that you're, following the steps. There's a couple of different steps during the setup where I do a submit, like one where it actually kind of submits just the general project. The user is your RCS ID. That is correct, right? It is an RPI. It's another account, or it's an account for you. You're using your RCS ID. It's an RPI account. It's an RPI server. We host that server. So it uses our name resolution, our password resolution, our Shibboleth user ID system, something like that. Okay, I forget I think it's Shibboleth server for IDs and so on. All right. So I would run through the process now and demonstrate it now, but there's a weird thing that sometimes happens, because you need to be either on campus or using the VPN to use to be using Perforce. And if I use the VPN and I'm streaming on what am I using? This thing, Discord, it can affect the stream quality. Basically, it has to go through an extra hop and validate certain traffic through the actual VPN, as opposed to me going directly to the Discord server and so on. So I'm going to ask you that you refer to that other video to go through things, as opposed to us going through it in class, because it does often have an impact on the stream quality, and I don't want that to happen. All right, so you hopefully, if you're one of the late adds to the class, you may or may not have your account set up yet. I'm going to try to ping them again today and see what's going on. But certainly, if you were an early add, you should have an account already. And make sure to follow the steps. And remember, there are a couple of different moments in the video during the setup process. Once you're all set up, then kind of Unity will always be doing the right thing with regards to the submits and the ads and so on. But the first time in, you may need to do sort of an extra add to depot, or add the project, like I did in that video over there. Okay, so follow that and so on. You will not be doing any adds, any gets, and so on from the depot, right? From the actual P4V program. Once you've got Unity set up, Once Unity's set up and using Perforce, you really don't need to be using P4V unless there's something fancy going on, right? Or if you're using some other program eventually in Game Dev 1, you'll do more in Perforce. But you really should be submitting everything automatically through Unity, right? That's the nice thing about doing Unity in Perforce first. It's reasonably automagic, right? Just once it's set up, it works nicely. And I'm feeling optimistic because so far we've got a couple of people actually seem to be plugged in. Now, once you're using it, use it often, right? Every time, hopefully, as long as you're on the VPN, as long as you're on campus, do those submits. Anytime you do some editing, submit it. Don't worry, it's not something that you only submit right before the project is due. Don't do that, right? Do it ahead of time. All right, do it all the time. Okay. The other thing I want to talk about before kind of diving into the lecture material is you will notice there is a submission point for the design, and I guess at this point I probably should go ahead and I will mute my microphone. Where the heck did my mute button go? There we go. Can you all still hear me? At least get a thumbs up from, okay, good. Excellent, thank you. And what was the other thing I needed to do? Oh boy, flew right out of my head. Hopefully I'll remember it. So the project 1, right? We have our first thing that's sort of due to, I remember, I want to get that silly, I've got to get my myself off the screen so that you don't see, so I'm not obscuring. There we go. Maybe I'll do this because for those of you who are brave enough to keep your camera on, and I applaud you for that, I'm going to do my best to keep my camera on as well. Okay, so project 1, the design is what's due today, and it's a very conceptual. I want to get a feeling for how you think, right? I'm not gonna. This programming is one thing where we sort of have to adopt, really, in some cases, pretty strict rules in order to get Unity to do the right thing for us. But when it comes to design, I don't want to necessarily jam things down your throat. I'm gonna, of course, hopefully, kind of tease certain things and kind of offer and suggest, and I want to get to know all you as designers and where you're at and what you think is necessary, and hopefully we'll come to things. I'll learn some new things, you'll learn some new things. So my design documents, I tend to make them fairly open-ended, right? The general thing, what I like to stress is, imagine when you're writing a design document that you should be able to take that design document and give it to somebody else in the class, right? So hopefully you can say, okay, someone else in this class should have a general understanding of the assignment, right? So the background, you don't need to regurgitate the background, but they should be able to take your design document and say, oh, okay, from this I could implement their ideas and it would work how they wanted it to, right? Not just the setting, but also potentially say, oh, okay, there's buttons that do these things, there's sliders that do these things, the feedback to the user that does these sorts of things. So you should be kind of considering, a audience other than just yourself in terms of this, right? So we want them to be complete enough to get those ideas across, right? It's also kind of like imagine them being greenlit by the studio, right? So it doesn't have to be totally pedantic saying, every line of pseudocode and so on. But a feeling for like, okay, I have 4 buttons and they're directional paths. So there's a north, a south, a east, and a west. When I press each one of those, it will let the player know that they should move in this direction by a certain amount. And then if they bump into a wall, they won't be able to move. That sort of thing. You want to really like describe the game, right? That's kind of what's going on. So this is due tonight. Ask any questions today, right? I like to basically always have like one last chance for everybody to ask questions and so on before the project's due. So typically I'll make sure that there's a class that day and then it'll be due that night. That's usually how I kind of work, as opposed to like, vanishing and you just have to hand something in. So in here, this is just a design, not the implementation. Consult the lecture slides for background, for description on the project. It's in there, definitely is in there. You should be thinking in terms of designing a UI and a narrative. It's mostly in that case. Now, UIs can have graphical elements. They can have buttons. You could even put images in there, okay? However, right, this is supposed to be the no video game, right, sort of thing. So it's mostly a narrative-based game, and we're focusing on the UI, the heads-up display piece of it, right? So I don't want a lot of moving objects around the screen. I don't want to really be able to see the world and so on, right? We're really kind of focusing on telling a story through these actions that the user is taking, right? They press a button, an action happens, the system is going to need to do something, it's going to give some sort of feedback, and not the typical feedback of moving something around on the screen, right? I want it to be descriptive. I want it to be, you could say, okay, this happens, and a picture shows up. We'll talk about getting images as part of the UI. But it shouldn't be, the player sees themselves move around on the screen. We're not going there. We want to be we're kind of old style-ish adventure game, right? So it's largely UI and narrative, not the typical game world that you'd see in these, typical games nowadays, right? Make sure you provide appropriate feedback to the player after each turn, right? That's part of the design challenge. How do you get that across? How do you get it across to the player that they are bumping into something, or that they moved, or that they're getting near something, or that they're getting further away from something? How do you play hot, cold, Marco Polo, whatever it is, through audio and through text, as opposed to being as obvious as moving stuff around on the screen, right? So there's some design challenges in there that we're going to use to work on our mechanical skills right there, okay? So it's turn-based, right? There shouldn't be stuff that's just automatically happening that time runs out, right? It's going to be something clicks, a turn happens. You click a button, a turn happens. That's the idea also, this turn-based sort of thing. Now, as far as the environment goes, it's really more about the situation that the player finds themselves in, right? What are the constraints? Is it, are they in a 10 by 10 room? Are they in a forest clearing, and if the moment they step across the tree line, they get eaten, something like that, right? So how do they know? I mean, we'll talk about, getting into the, how the geometry works, how vectors work, and so on. So we can sense, where are we in relation to other objects and so on, right? So what are the constraints? What is the challenge? Keep it simple, just a few steps, right? We're not writing Legends of Zelda or anything like that. We just want to be simple. Okay, you've got to maybe find an object within the room, and you need that in order to complete the task. Really, really simple. Maybe there's one trap in the game, or some area where you smell rotting flesh. So don't go closer to that because there might be a zombie or a pit or something. Who knows, right? So a little bit of that. So the basis for the UI starts off with a set of buttons that provides the equivalent of an on-screen directional pad, D-pad, up, down, left, right, north, south, east, west, forward, backward, left, right. You could get fancy. You say, you might have turn left and right and move forward and back, right? That's a little bit different than just kind of strafe left and right, where you just translate, you translate your position as opposed to rotating and then moving, right? Two different types of motion. We'll talk a lot more about later when we talk about character control. But think about that, right? That's one of the things. How can a player move? The most typical way is up, down, left, right, without doing any kind of rotation. If you're, want to wrap your brain around the idea of, okay, if you turn left, then what happens, right? Then how do you maintain? It gets a little trickier, so be careful of that. What things will the player encounter? Keep it simple. Don't get carried away. Don't have a 12-part program. The TA and I are going to need to, Justin and I are going to need to kind of grade these things in a reasonable amount of time. So don't get too carried away. Shouldn't be epic quests necessarily. How will you lead the player to the goal, right? Players just wandering around, that's not all that fun. There's got to be some kind of feedback. I like there to be audio feedback, but you could also describe to the player what's happening, what's changed during that move. When they hit that button, what happened, right? At least inform the player that they are moving in the right direction, perhaps. The classic hot, cold, warmer, colder, you smell it, you don't, you hear it, you don't, and so on, right? The deliverable tonight is no more than a page, and perhaps you might have a simple screenshot. And by screenshot, it could just be a simple drawing saying, okay, here, the button's over here, and I have a text box over here. I have a slider that's going to control the overall volume here. I have a box that's going to show the character you encountered over here, or the item that you encountered over here to kind of pop up, sort of thing. Something like that, right? So very, very simple heads-up display. If you look in the lecture notes, you'll find that there's at least the example that I put on itch. There's even a screenshot in the lecture notes of the version that I did, simple one. So if you want to review back to that. Okay, so the deliverer should be no more than a page of text, perhaps with a simple screen layout, sort of a wireframe, as they call it. Not all the way figured out, but enough to give an idea. All right, submit as a PDF, a Word document. It's going to be submitted through here. Right, so you're going to get from here, and you're going to get to the assignment, upload that PDF, Word doc, whatever it is. All right, piece of cake by midnight. All right, you absolutely can. That's totally fine as well. Yep, you can. In case that didn't come through, you can write your submission directly into LMS. Right, so text submission here. Right, can hit that. Just go ahead and type. Or if you've put it into Notepad or Notebook, whatever, and you just want to cut and paste it, cool, fine. Is it a web link to somewhere? Okay. That makes downloading it a little bit trickier, but I suppose you could even have a Google Doc somewhere that you could link to. Don't get too carried away. It's best to have something that's actually submitted, so we have a living document, a living version of it there. All right. Okay, I think, any questions on the assignment, right? It's 3 out of the 10 project points. And then as we get into the project, we'll really talk about, how you implement it from there and the feature points. That's where the meat and potatoes, pardon me for, I'm an omnivore. My analogies sometimes run in those directions. But that's where, the bulk of what you're going to be doing and the points you're going to be getting and so on is really from implementing features and executing the design, right? So this is really to kind of kick things off so that we're all on the same page and you know where you're going and so on, right? So it's 3 points out of the 10 points for the project. And then the feature points will be the ones that kind of just accumulate over the course of things, right? Your experience points, they're going to just level up through the whole class as opposed to the so think of the project points as being quest completions. You get a certain amount of points for those. All right. Let's see. Let me double check. So this is like a text adventure game, yes, but use the UI buttons, right? We want all feedback. Oh, there, I see the docs and animated now. Use the UI, right? This first one is really about kind of mastering the Unity UI and thinking about how we interact with the user and how you use a heads-up display in a game. It also gives us a nice, easy way to do a little sort of text-based programming and start introducing concepts as opposed to really getting everything all at once. If you're used to Unity, enjoy the experience. It's going to be a little bit, different. All right, so let's go back, and now I'll go back to the unblemished version, and we will talk about C# programming in Unity. All right, we're going to save visual programming for a little bit later, so we're going to kind of we're going to stress the C#, the traditional C# version of it. Now, where we left off last time, and let me see. I don't know if I have Unity even running here. So I'm going to go ahead. I'm going to run the Unity hub. I'm going to pull up Unity in the background, and the important part is really going to be what happens in, let's see, I'm going to pull up AM temp. I have a temporary project here, and I have now, I'm changing versions. I had to clear up some room. The one bad thing about having too many versions of Unity around on your machine is they do tend to take up space, right? So I wound up with 80 so gigabytes that, let's see here, that wound up clogging way too much. What is going on here? Non-matching, continue. All right, so with that going in the background. So be careful. Don't install if you wind up installing the latest version of Unity 2021 and you have the 2021 older versions, you might want to go into the hub and uninstall the ones that you're not using just because they take up a lot of space. So that's one thing to be careful about. And most of the programming we're going to talk about today is the kind of stuff that's going to be basically within Visual Studio, right? So it's going to be within a script, within a C# script, right? As opposed to visual scripting inside of Bolt. All right, so we'll let that kind of keep going in the background here. Whoops. All right. So we're talking about intro to C#, a little bit about syntax, variables, and structures, and some logic loops and conditionals. So it's going to be fairly fast-paced. Again, I know most of you have taken at least one other computer science course of some sort. So hopefully some of these concepts will be familiar. If they're not, do feel free, ask questions, put them over in the chat. If it's unclear, I'm always trying to refine this stuff, and every time I approach it, my ADHD comes in and I say, oh, I can do this part a little bit better, or try to make it clear. Sometimes it becomes clearer, sometimes not, so feel free to ask questions as we go. And also, just double check on that. Okay. All right, so just quick review that we have game objects. Oh, okay, now here's Unity. Just in time to get in the way of things. All right. Game objects, those are the things we're going to be working with. The nouns, right? The highest, generally, other than scenes, they're going to be the highest level in terms of programming, right? The things, the nouns, all independent objects, visible and invisible. So in Unity, we'll be talking about things like cameras, lights, terrains, vehicles, objects, obstacles, the player, or a player, an audio source. An audio source is kind of a tricky one because an audio source can be both a component and, potentially a object, but it's one of those things. Then we have the components, which are containers for groups of related functions and properties that a game object will use in order to be able to implement stuff, to actually have actions and agency and so on, right? And those are going to be things like the transform, the sprite render, the collider, the scripts that we write, whether they are Visual Studio scripts, C# scripts, or Visual scripts, all right? Then within the components, they're going to have their fields or properties or their data, right? The data, the adjectives, the attributes contained within components, things like the location, the health, the orientation, the ammo, the text to be written, the storylines, and so on. These are all data. Functions, the rules, the verbs, they are contained within components, things like move, fly, wrap around, block, aim, print, tell the player, take a turn, right? Those sorts of things. The events, which we're going to be kind of creating our own events in the first version, or kind of pseudo events, right? The conditions, the circumstances that we care about for a particular rule, or in order for a particular rule to be enacted or enabled or kind of executed, right? When a button is pushed, when two objects touch, when a button is clicked, when a frame is updated, when a turn is done, every second, etc., etc. All right. Now, last time around, we did call a function. We did the first time, and we did it really, really close to the end of class. So let me see if I'm going to reiterate here. So we were back in Unity. Real quick review. And what scene were we in? We have Unity here. We have the adventure game. I created a little scene. And this scene, we'll go here. Adventure game. We're in the adventure game scene. Just wanted to make sure. And within the adventure game scene, we had the canvas, we had a global light, we had what was going to be a cartoon. Oh, the cartoon sound effect that was there. All right. Now, up here, let's see. Did we write a script? We wrote the game manager script. Okay. And the game manager script is not on an object in the scene. Well, that's interesting, because the game manager, I think we put it over here in the lobby. I don't know where we left it. So the interesting part here is that you'll notice, And as I'm looking around, I'm saying, oh, where did I put that game? Where did I put that script? Now, scripts can actually live on their own, right? Down here in the asset folders, just in case it wasn't confusing enough, things like scripts here. Here's the game manager script. It is just another asset. It is just another file on the hard drive, right? So it exists. If I click on it and I say show and explore, you can see, yes, it is actually a file, a GameManager.cs file. It also has some special sauce with it, the GameManager.cs.meta file, which is a Unity extra file that helps Unity maintain it. But the important thing is that this GameManager.cs is just a text file that is just your CS, your C# script, which is what Visual Studio, you're going to be editing in Visual Studio, you're going to be executing it inside Unity. All right, so it's just a file. Now, once it exists, I can decide, all right, well, here, let's go to let's go to our main scene again. So not our lobby scene, but our adventure game scene, because it looks like that was, the intent there was to have that. So let's make sure we're here in adventure game. We have the cartoon sound, and we had the global light, right? Sort of the default things. We had the main camera, but let's create an object here. I'm going to create an empty object called Game Manager. This is my Game Manager object, right? And I want to assign the script here, this Game Manager script component, I want to put it on that Game Manager object. Now, I think I can do this. Yep. That's one way. I can just drag it and put it on here. Now, I could have also said add component, and if I typed in Game Manager, I could add it like here. Now, I just did something which you want to be careful about. I just added this script accidentally. Well, I did it on purpose, but you may, in certain circumstances, you may assign the same script multiple times. You can reuse scripts. Like I said, they're just a file. So you have to be careful that you only, when you do use them, you make sure to only use one of them. Like, so here we have the Game Manager object, which has one Game Manager script component on it. All right, if I double click on that, sure enough, Visual Studio will come up and we'll see the actual script, okay? So again, review. Within the scene, we have a Game Manager object, which is just sort of a container waiting to have some components given to it. And then within the Game Manager object, there are scripts and components, and I just happen to have created a Game Manager script. And in that Game Manager script, for now, I'm going to get rid of update. I'm not worry about that. We have a sort of special case in the component that has, it will automatically create this class for me. And one of the events in that class or in that component is this start event or start function, start procedure, right? It's really, you think of it as an event. So this event happens the moment I hit play, and then this statement is called, this print hello world. All right, so press save here. I come back over here. And if I were connected to the Perforce and on campus, I'd probably see a little edit, a little check, or a little plus here saying, yep, something's changed, but here for now I don't. So we have the Game Manager. I'm going to press play. I may hear the cartoon sound when I press play, hopefully. You'll see it's linking, compiling. The boop happened, yep. And in the console window, right, the console window is our friend here because it lets us know kind of what's going on. And I'm going to put the console right there, right? I can move it around, and I'm going to have just short messages in here, the console window. Hello world, so I can see, yes, that code executed. Now, let's talk about this print statement, this idea of the print statement here. All right. So we've called our first function, or our first method, we call it that, right? Unity has a built-in function to output text messages to the console. This is something that we're going to use for debugging, right? So it's really, really handy to see, okay, you might be tempted to tell the player something by printing something, right? Someone had asked, is this like a text adventure game? It is, but don't use print. You might, in a traditional text adventure game that was purely text, you'd probably just be printing to the screen or printing to the console all the time. The one thing we don't want to do in the end result, we're going to use printing for debugging, but we're not going to be using this for really the feedback to the user, right? So that's one thing to be careful of. When you see this print function, you might be tempted to overuse it. It is a debugging tool. It is there just for us to have a convenient way of outputting text to the console. The console doesn't exist in a running game, really. Don't think of the console as being something you're really going to use to talk back to the player, but it's there for us for debugging, right? So we have the function here, the function name called print, it's printing text to the console. There's a set of parentheses that will tell us, yes, execute the function and contains the data or the input, the variables. In this case, we just have a single variable, which is a string, hello world. So it needs that in order to do the function. That's the argument. In source games, players often interact with the console. That is absolutely true, right? If we were just doing a traditional text-only game, the console would be cool. But we're or is that a new genre that I'm just woefully where you provide the source code and people actually run it within the editor? I don't know. Maybe that's a new thing. Could be. But don't do that, right? Engine that most Valve's games run on. Source as in Valve, okay. Well, you can write things that look like a console. Okay, yeah, it's the idea of having a console and having text-based input, that's totally fine. But now we're talking about a special sort of thing. So within the source engine, you may have a console that's meant to have player interaction, but you in our case, this is really debugging. We can create console. Okay, don't get too sidetracked. Okay, for our purposes, this console and this print statement are considered to be debugging tools. If we want a console-like experience or text-like experience for the user, that's something we're going to want to have control over and be very explicit about. We don't want to give them like some kind of just random debugging message that we used while we were developing. That's not what we want. Maybe you do, but anyway, you're going to want to have a little bit more control, and you're going to say, okay, I have a text box that I'm outputting things, and maybe they have to respond to things and so on. So those activities will do, but they won't be, okay. So anyway, this is our print statement. We got there. Wonderful. All right. So C# and object-oriented programming. So we have this idea, properties and methods, and it's not just going to be the typical print this, right? That's first line of programming everywhere. We got to do that. But C# is an object-oriented programming language, and Unity is definitely heavily reliant on these object-oriented kind of structures, components, and practices, right? So everything in C# is associated with an object through classes, all right? We should think that way. Before we break the rules, let's consider, quote unquote, the proper way to do things, right? So everything in C# should be associated with an object described through classes or structures. Structures are going to be a special case. Used to be kind of the normal thing back in the day when we were just, C and C++, a little bit more. We'll talk about structures a little bit. But usually we're thinking of these classes that we're using to define what these objects will be like, right? A class is a definition, and ultimately that class is going to be instantiated as an object, right? So we have this class, which is our sort of blueprint, our design to say, okay, we need this functionality, we need this data, and it's going to be self-contained within an object eventually, right? So think about this. In real life, a car you could think of as an object. It has properties, it has such as its weight and its color, and methods such as drive and brake, right? So the user can interact with it through certain things. The user doesn't go in there and actually turn, grab the wheel or grab the control arm on the whatever. It's not going in and changing stuff on the motor, the engine. you're controlling it through an interface, a steering wheel, a pedal, and so you sort of like, you drive. You don't go down all the Lua. What? You don't go all the way down and jump into all of that kind of hidden structure. You do things at a higher level. You work with it at an interface that the designer provided. Drive, brake, right? Hit the brakes. You don't manipulate the brake pads directly, right? You drive. You don't manipulate the carburetor or the fuel injectors directly, right? So a class is like an object's recipe or a blueprint for creating objects of a certain type. All right, so think of these classes, these class files, these scripts as your recipes, right? So more about an object in the official sense, right? An object is the basic unit of object-oriented programming. It is patterned after this notion of having real-life sort of entities that stand on their own. They have data that they manipulate that is not available to the outside world, but ultimately determines how they operate, right? A typical C# program creates many objects, sometimes of different types, sometimes of similar types, right? You interact with these objects by invoking their methods, right? There are circumstances sometimes where you actually go in and touch the data if it's allowing it to, but usually you are interacting with an object through the methods that it provides to you. An object will consist of, inside now, right? It has some sort of state, which are those attributes of an object. They may be the properties of an object, right? So we'll get into a little bit more the subtlety of some of these words, but imagine the state is sort of like what's in there and how it presents itself, kind of what state it is in or what color it is or what size it is at any particular moment, right? It may be using some internal structures to really come up, in the end present that, but right. It has behavior, and behavior is presented by the methods of an object, right? These are the things that allow it to do stuff, reflects the response of an object with other objects, and so on. And an important thing is that objects have to have an identity. Now, this sounds more complicated than it is, but it's really just one way or another, an object should be uniquely addressable so that it can interact with the system and other objects. Right? When you have a class, ultimately you are then going to be creating objects or instantiating objects of that class. And each one of them are going to have some way of referring to them. They're going to have an identity, right? An object should be unique. There's going to be some way to refer to that object. And that might be as simple as having a name, right? Some kind of name that we're going to refer to it as in our scripts, all right? Now, it does get a little bit more finessed in terms of some of these things. Like you'll hear methods versus functions, properties versus fields versus attributes. I'll leave it to the computer science courses to kind of take you down those paths in far more detail. But for now, we're gonna use some of these terms in a little bit of a loose way, but sometimes, I want to make you aware of some additional capabilities and things that, if you want to get into really good practices, you can take advantage of, right? So a method is like a function, right? A method is specifically a function that is associated with an object. A function in general, something like square root, right? Or a function that does, clamping of values, that may or may not be associated with an object, right? So when we're really talking about something that is associated truly with an object, the official term is really an object's method, all right? Now, a field is sort of the specific way of saying, okay, this defines the bit of data within an object. Now, a field is a little bit more general than something that is a property, right? Properties and fields, fundamentally to the object, they are very similar. But officially, a property is the way that is a field or data is sort of presented to the rest of the world, right? It is a property of something, right? It's something, some data that potentially the rest of the world, the rest of the engine needs to know about. So Yeah, it's a little bit fuzzy, right? So sometimes we'll say fields, we might say properties, and sometimes properties will have methods for accessing them, right? Fields and methods also have something called attributes that tell you about behaviors of those fields and properties and so on, right? Fields and methods. And the first thing we're going to start talking about these things called private, public, and even a few more Unity-specific ones, serializable, etc. Private and public are going to be really, really important right away, because this idea of object-oriented programming is that some things the object wants to keep private to itself so the rest of the world doesn't break it or touch it. Like in the case of the car's engine, we don't want someone manipulating the brake pads directly. We want them just hitting the brake pedal. So the brake pads would be private to the car as opposed to the brake pedal being, that's what the user uses. That's a public interface, right? Something like that. So that's sort of where we'll get into things. So in real life, you'll largely see a mix of these terms around properties, attributes, fields, and generically, we can think of them as being the data that's in an object, right? And as you go from language to language and so on, largely different languages sometimes are using different jargon, different terms, and so on. So it can be a little bit hairy as you go from one to the other. But just think in general, the important part is that we're talking about the data that's in an object and the functions that are in an object when we start talking about these things. All right. So, for example, here, a little bit more of an advanced one for those of you who may have seen some of this before, this notion of, say, well, okay, private, right? So maybe internally an object needs to know about its own health, but we want to describe a specific way that the rest of the world can get at that. So it might have a public property or create a property which is a public attribute, right? A property is a public attribute versus a field which is a private attribute. And we use these private and public and provide some interfaces to them. Don't worry too much about that, but this notion of remembering those, right? I like to introduce this right away, and we'll refer back to this one. So don't worry about this being, sinking in too far, but just be aware of these things. You'll see this get and set turns up in a bunch of places. Because sometimes, again, it's all about this idea you want to start thinking about when you're designing in an object-oriented way. What things does this object need to let the system or in other programs or even another programmer, what do they need to know about it versus what do they need to internally do based on that, right? And we have a special C# etiquette that can help us leave fields private and use properties as public interfaces, right? So this kind of combination of public and private, right? This is sort of an advanced topic. So what this is doing here is saying, oh, okay, I have something which is a class that's a date. Now, imagine you wanted to have a date for something, and part of the date was the month. And you know that there are 12 months. There aren't 13 months. There aren't 15 months. There's no 0th month. So therefore, you want to, anytime someone uses your data, you want to make sure that the month that they provide is between 1 and 12, right? So C# and often other object-oriented programs or programming languages have ways to help you enforce that sort of thing, right? A little bit of an advanced thought, right? So let's step back a little bit. Right? Stepping back, okay. Classes and structures are the two basic constructs of common types, the common type system in C#. Each one is essentially a data structure that encapsulates some set of data and behaviors that belong together as a logical unit, right? So we're normally going to be writing classes, but I want you to know there's this other thing out there you may hear about, you may see, called structs. So don't be scared when you see them, but we're going to be mostly dealing with classes, right? They are the common data structure that we're going to use. We're going to create new data structures of our own classes with our own recipes. There's these other ones out there called structs as well, and often they kind of look almost identical, but not quite, right? So a class or struct declaration is like a blueprint that is used to create instances of your object at runtime, right? You might define a class or struct called person, and then person becomes the name of that type. And if you declare and initialize a variable P of that type, person, P is said to be an object or an instance of a person, right? So you have the recipe, and then you have the actual thing the actual object that is created from that recipe. You could have multiple instances or multiple objects of the same person type, not of the same person, but of the same person type. And each instance may have different values in its properties and fields. It may have a different name, may have different height, may have different weight, may have a different set of interests, right? So we have all kinds of people that are each individually a person because they all are created based on this class, right? So we have these classes. So in general, we're going to be using the class model. We're using them to model this more complex behavior, data that is intended to be modified after the class object is created, passed by reference, and so on. We're going to not worry. So when in doubt, we're going to use classes. Structures are sort of a sibling of a class that is more designed or left for sort of optimization and sort of special cases at this point, right? So don't worry too much about them other than that realize that they're there, and until you get specific to it, structures and we'll talk about them later, right? They're really nearly identical except for one mechanical bit, which is you may or may not have heard of heap storage versus stack storage, right? There's different types of storage in the program, the heap and the stack. And really one of the main differences between a structure and a class is where it exists. Does it exist in the stack or does it exist in the heap, right? So some of you are going like, oh, that's it. And others of you are like, I have no idea what I just said. And that's okay. We're going to mostly deal with classes, which are on what we call the heap, right? We could have as many of them as our memory will allow, and it's going to be great, all right? That's why we use classes. So don't worry, even though they may look very similar, we're going to use classes. All right. Now, if you need additional resources, there's always lots more, right? Unity 3D has Learning C# and Unity for Beginners. And of course, Microsoft, which is one of the originators of C#, there's a bunch of .NET C# tutorials out there as well, right? So there's loads and loads and loads of resources. And we're going to focus on the specifics of really using C# inside Unity and potentially programming inside a game engine. So we're not going to get into necessarily every crazy feature of C#, and instead we're going to kind of focus on, how it works within Unity, and potentially maybe even keep it in the back of our heads that, maybe there's even going to be other scripting languages that we use inside of game engines as well. And this is just how C# works in here. And maybe someday, hopefully, if you've gathered enough information, you can apply some of this knowledge to other environments as well. Now, first off, one of the big things when we're writing in C# for Unity is we're not writing programs, we are writing components. And that is also largely one of these issues of like scripting versus programming, right? We are designing and implementing kind of smaller chunks that fit well within the architecture that have a basic kind of class and structure kind of already in place for them, right? Which is what allows us to write components. We don't write programs. Whereas in a full-fledged from the ground up C# program that we might be writing, we might have, of course, the program class, and have a main entry point and arguments that are passed by the system into our program, and we would then all go run everything. Now, that we're not doing. Instead, we're always using our components within the Unity engine, right? And we have ways to interact with the Unity engine, and 99 times out of 100, 99 times out of 100 at least, we're going to be using this mono behavior, this kind of class that Unity has already provided for us that gives us sufficient interfaces to the engine to kind of get us going, right? So we're going to be working within that engine, not just writing a program from the ground up, right? So that's also the kind of the big scripting versus programming coin there, the two sides there, right? We are writing code that's fitting within an architecture that's already running, so ours are kind of scripts. as opposed to coding or programming from the ground up, right? So here we're seeing, the moment we created a script, this might look a little bit familiar. If you went ahead and created a component of a script, this is kind of the boilerplate, right? The standard thing that Unity gives you, right? It has a public class with whatever the name of that you decided that you gave it when you asked for a new script. And it says it inherits, that's what this little colon is here. It means it is based on the mono behavior, which is the thing, the basic blueprint, the basic class that Unity wants us to use to create our components, right? I'm kind of surprised that it should have been called mono component or something like that, but it's mono behavior for historical reasons. And two of the main events that component will use to talk to the system or for the system to talk to that component, two of those main events are the start of play, when you press the play button in the Unity editor, or the player starts the game. And then there's also the update function. Update is called once per frame. We're not going to use the update function in our first program because we're going to be a turn-based game as opposed to being driven by frames on the screen, right? Update is called once per frame update, right? So if your screen is drawing at 60 frames per second, you've probably heard that term, number for FPS in your game. That would be how often your update method would be called, or your update event would occur. We're not going to worry about that one. We're going to start off with this simple start, which is when the game starts there. All right. And remember, components are classes. Welcome to object-oriented programming in a big way, right? So from the get-go, you're using object-oriented techniques like inheritance, and you don't get the feature points for using inheritance in this way. Some people try to pull that one on me. That's not true. So inheritance, we're going to get into more specific cases about deriving classes and being fancy. But for now, be aware that you are doing full-fledged object-oriented programming because you're using components that are derived from another class called a monobehavior, right? Components inherit from monobehaviors. They're based on monobehaviors. They have certain methods that are automatically called at the right time. They're the events that are sort of built in. There's start and update. You see those, and there's many more, right? Be careful as you create components, as you write scripts. If you have compiler errors in them, it will prevent your game from running. Or your game might run and just, you'll see it just is not doing the right thing. So best case, it actually sort of runs. Typically, if you have a bad syntax error or just a total compilation fail, Unity won't even run, right? So one of the things you're constantly going to be referring to as Unity is running is your good friend, again, that console window, right? The console window, if I come over here and say I want to edit this, and I do some stuff in here, and that's just bad code, right? Doesn't know what that is. I come back over here. In the console window, you'll see error, right? So pay attention. Always pay attention to the console window, right? Especially as you're editing code, because you might think that, oh, I just wrote some valid code, and it turns out you might have a bug in there. So this is the first area where that link between Visual Studio and Unity comes in real handy, because you'll see here, error on this line. Let me double click on that. Brings me right here. It says, okay, there's where my bug is. Let me get rid of that, save it, come back again. There we are. Now, safety tip, important safety tip. You'll notice I was going back and forth while I was in play mode, which is not a great thing. Highly recommend, well, let's see. Sometimes Unity will be churning out all kinds of extra warnings here, so don't get too worried about warnings, right? Should not be capturing while there is a hot control. All right, that was probably because I was running. I'm going to clear that out here. But you always want to be careful about what's going on here, and you want to be careful what you're doing when you're in play mode. Now you'll notice when I hit play mode, my whole screen gets slightly blue, right? That's to let me know that I'm in play mode, so I don't accidentally then go and edit things without realizing, because you really only want to be editing things that you want to save, that you really want to keep, right? Yes, someone put in there, the horrors of editing your project and then you realized you were in play mode. It happens. Happens a lot until you realize there's this feature here. So we're going to go File, let's see, Edit, Preferences, and an important thing here is we're going to go to Colors. All right. And if we scroll down here, where are we? Play Mode Tint. Okay. If there's one thing you learn from today, it's that you should set a tint for your play mode so that the whole Unity editor will change color when you're editing versus when you're playing. Sorry, yeah, it'll change when you're playing versus when you're editing. Okay, so that's important. Let me change my tint mode just for the heck of it. I'll set it to that just to show you kind of what happens. So now if I come back here and I'm ready to, I know I'm in play mode, so I don't accidentally start editing stuff and objects and so on, and everything goes. I lose things, right? Because you will lose your changes as you go back and forth, right? Because the state of the system is changing. The moment you hit that play button, it kind of switches you over into a virtual machine version of the game. So be careful about that. All right. So emphasize the console window, our scripts, our play mode, jumping back and forth between Visual Studio and where we are here. All right, so components are classes. Unity uses C# for other things too. Classes aren't necessarily the only game in town, but for us starting out, they're going to be the main way we do things. There are libraries, there are other types of entities, components, systems. There are other things like scriptable objects. You may create, a math library and so on. These are things you can create in C# as well, and there'll be different classes other than components, right? We will look at libraries, entities, components, and systems. That's a far more complex paradigm. It's part of the data-oriented technology stack that's inside Unity that is still considered sort of a beta thing. It's not quite, something we're going to jump into in game architecture. We talk more about, underlying architectures and systems like that. But for us, we're really going to be looking at monobehaviors, components, right? So let's start with some basics, some important syntax of C# so we can kind of hit the ground running, right? This is a whirlwind tour, and then we're going to learn a lot more by doing, right? So first, some rules. Comments. One of the first things you should learn is document your code. Put in comments, right? Double slashes, if you put a // double slash indicates a single line comment. I want to see these. You need to put these in for your feature points, right? You're going to flag things that you implement as feature points so that we see them when we go for grading, when I search for them, and then we give you credit. If you don't put comments in to indicate where your features are, we won't find them. You may not get credit for them, right? So this // feature, so on, that's important. So this is a single line comment. You also have block line comments. You could put your feature point comments inside of block comments as well, and that just basically means you have a starting and an ending indicator for your block comment, right? These are likely the two types of comments you'll use. If you're working as part of a larger team or you want to even get fancier, you can use these kind of triple slashes that are comments that are meant to be used as part of an automatic documentation system, so you can create documentation for your code after you create the code. So it's more like a markup language. You can kind of think of your commenting as part of a markup language. So you'll sometimes see that, but we're not going to really worry too much about that. Worth seeing and just looking at code. What is that? That's a comment. If it's commented, it goes away. It doesn't do anything. The computer just ignores it. It's really there just for us. Right? Now, first thing that is there not just for us, that is very important to understand. You'll see a lot of these different types being used, and they all have particular purposes and reasons. Our container sort of parentheses or braces, angle brackets, regular brackets, right? They look very similar, but they are certainly not interchangeable. Whoops, they're not interchangeable, right? We have these things called braces or curly braces. We use those when we want to create structure within our code. We want to say, okay, this is a chunk of stuff that all is sort of part of the same thing, functionally has stuff to do with other things, and also should be executed as a block, right? The moment you start, once you're inside one of this brace, generally think of everything that occurs from this one to the other one as being some kind of unit, right? So even your methods, your procedures, your functions are going to use these braces to indicate where they start and where they end, right? Typically we refer to these as scoping, right? These are our scoping braces or curly braces, or right? That's that. Then we have parentheses. Parentheses are used for calling a function, passing values, indicating what the arguments are. So when it comes to arguments for a function or a method, that's what those indicate, right? So when we call a function, we say print, we use those, right? When we're defining a print function, we may very well be using the combination of these to say what the arguments to that print function is, and then these curly braces to say what is the body of that print function. All right, those two. Square brackets, right? Now we're into the brackets. Accessing an element within a collection, right? We'll talk about what collections are, what arrays are, what lists are. And there, when you have a container or a data structure or variable that can contain multiple values, and we need to be able to reference elements within that collection, that's when we use the square brackets for that, right? So that's more a data structure, a data access scoping here. And then C#, we reserve these fancy. Okay, I've got to pause for just a second because I have a delivery coming. I apologize for that. Let me mute my microphone for just a second, and I'll be right back. Wow, what's going on? All right, I'm back. Settle down. I don't know what just happened there. I had, sorry, I had to do that. I had a delivery last week, of a grill, and the shipper put their forklift right through it. It was great. So they totally destroyed. Hopefully that is not. I'm gonna let that go to the message. Okay, so yeah, have to take the old one, bring in the new one. Sorry about that. Okay, and we recorded the whole time, so don't worry. I don't think you. Yeah, how do you mess up that? And they tried to hide the damage too, which was really, really great. So anyway, all right, time is of the essence. We have to get back on track here. 11:11. All right, so angle brackets are going to be. Can everybody hear me? We're okay. We're back. We're normal. Okay. All right. So angle brackets, passing a type to a generic function. This is if you've never dealt with the generic functions or generic types before, this may be one of the newer things you're going to have to deal with, but you will quickly acclimate to it because it is such a common thing that gets done in Unity, because you're going to want to say, well, okay, what type of component? How do I look at a rigid body, or how do I get the script, or how do I talk to this other thing, and so on and so on. And that's going to be how you access components of particular types, right? So you have generic functions that may correspond to a function on any number of different types of components. So we're going to use that to do some cool stuff that way as well. All right. A little bit more background. Naming conventions. This is the way Unity recommends. I like to see things. It uses what is called camel case, which is similar to Pascal case, but it's a little bit of variation here. When you are naming things such as variables and functions and so on, you want to use multiple words in the names. You want to capitalize each new word. The first word is special, though, because the first word, whether you capitalize it or not, will depend in the Unity world, in the camel case world, on kind of what it is, right? What type of thing we're naming. So in Unity, you'll see that functions and Unity user-defined classes start with an uppercase letter, right? So when you have a component that you're building, the name of that component should be capitalized, okay? And functions within there should also be capitalized. Variables, so variables that you have, any data that you have, that should start with lowercase. So functions and classes start uppercase. Variables and built-ins you'll often see using lowercase. So for example, this is a function, game object, rigid body, and so on. This is a variable, int, float, public, private, right? So the keywords and data types that are part of the C#, they're usually all lowercase. And whenever we define a variable, not a type of a variable, but a variable, we're going to have lowercase, right? So this way, when we read the code, we understand what's going on. We don't get confused, because one of the weird things, or not weird, one of the things that just sort of happens is there's sometimes there will be things that are named similarly, and you want to be careful, because you may have game object that starts with a lowercase g, which is the game object that is kind of currently the game object of that is the parent of the component you're currently working with. That's the lowercase g. Whereas opposed to a capital G is the type game object. All right, so case is important, and everything is case sensitive, right? So you can't just be arbitrarily using upper and lower case, right? So get into good habits that way. All right. Almost all of our coding is going to occur within the scope of a class, usually because of an event, right? So here's again that typical kind of thing. We have and here's the first. I should fix this. That should be capital M there, right? I should just leave you to. Someone should point that out. I got to leave that but just now. This should be capital master, public class master, and then mono behavior. You'll notice that's a capital there, right? And start and update, they're capitalized as well. These are events within this class, the events that the class will respond to. All right. All right. So we have the idea that we're going to have these functions or methods in there that are going to be ultimately controlled by data as variables, or they're going to manipulate variables or the things in there. So let's consider what is a variable. Right? What is variables in a generic sense, and then more specifically a field or a property and so on. Now, variables are declared with a type, right? You again, if you're coming from another language, you might be saying, "Oh, I didn't have to declare what type it was. I just declared a variable, and it didn't matter if it was text or a number or whatever." We want to live in a world where, and I highly recommend that you consider C# to be strongly typed. So whenever you use a variable, when you declare a variable, usually, unless you have a really good reason, you should give it a type. So we have a type int, which is going to be integers, which is numbers with no decimal. Float, which is the standard unit, standard decimal numbers inside of Unity. They're always designated by this F here, right? We use floating point. We don't use doubles. You may have heard of doubles. That's another type of double precision. We're always going to use floating point. So whenever we need a floating point number, it's got to have that 0.0 point something F in there, right? So get used to being explicit about your integers not having any decoration, and your floats have a F at the end of them. We also have a type called a bool. Really useful when we come to logical operations or flags, like we want to know, is the player alive, is the player dead, right? Is it true or false sort of operation? For that, we have something specific called a bool, whether it's true or false. And then we have a string, right? This is another one of the four main basic variable types. A string is a sequence of text characters, things like hello, or a name, or something like that, right? So it's kind of our first more complex data type there, and it can be of variable length and so on, but it's kind of fancier than our simple int, float, bool, which are all just always the same size, always just, kind of a simple number of bytes, and there's a representation of them. Then we have our more complicated things like classes, right? Classes are collections of rules and data in compound types that are either part of the engine or part of the things that we create, the things like vector2, vector3, game objects, rigid bodies, and so on. They're not just a number, not just all text. They might have numbers that represent all sorts of different things inside and so on. And then we have our friends, I'll just note them here, structs, in case you haven't. They're like classes, but quote unquote on the stack, right? They're short-term, limited scope, complex data structures. Let's not worry about them too much. So normally, when you are creating data, when you need to have some sort of data structure or variable, you will declare it, right? Here's the easy version. When you declare a variable, you give it a type, give it a name, and optionally, you include an assignment as part of that definition or declaration, right? Int health points equals 5. And notice this is an integer, so there's no 0.0f at the end. Whoops. Right, so it's just int health points equals 5, and then end that statement. That's the simple one-line version of that. That's if it has a initial value. On the other hand, you don't have to provide an initial value for variables. You can just say, oh, int health points, and then it's sort of up to the system, up to the programming language, up to whatever, to decide what is that initial value, right? Integers, by default, their initial value will be 0. Strings will be empty, floats will be 0.0, but it's a good practice to get into to initialize them to something that you specifically want them to be. And Unity will do some special things when it comes to the Unity editor and how we modify things in the Unity editor later on. But these are the kind of the basic ways of creating data and doing stuff with it. Now, more complex data, you'll see that there are things like vectors, which might contain an x value and a y value, and a vector 3, which has an x value and a y value and a z value. So there's like multiple components. This is going to be one of our best friends, right? And vectors are often used to store 2 or 3-dimensional values, or duples or triplets, right? Pairs or triplets. And in order to use those, we have to have a bit of special syntax to do that. Like, so we have something where we say, okay, we have vector 2, my position, and because it's a class here, not just a built-in type, we have to say, oh, give me a new, and tell it what type of vector 2 and what its initialization is. Right? We'll do more of that later. But sometimes when you have these classes, you need to instantiate the class and construct that class. That's what's going on there, right? And once that class, or once that object of that class type exists, then you can do things like refer to the individual members within that class, within that object, right? Here's X and Y within that vector, right? We'll discuss them a lot more later. I mentioned this before, this idea of scope. Right? Within the class, within that object that's created from the class, some things you're going to want the rest of the world to be able to touch, other things you don't want them to touch. You want them to be able to change the radio, but you don't want them to be able to change the wiring of the radio, right? That sort of thing. So we have two special scoping attributes to do that with, right? We have something called public and private. And there's going to be another one called protected, which we'll get into when we talk about inheritance. But for now, let's talk about public and private. Public means it has global scope, meaning anything can see it, anything can access it, and things can change it, right? So if you declare the brake pads to be public, that means anybody can go in and touch the brake pads. If you declare them to be private, it means nobody knows about them except for that car itself, right? So public is accessible from anywhere in this script or another script, and it must be explicitly set, whereas private is accessible only from within the script or within a certain function and is assumed by default. So if you don't say something is public, it will be private, right? So it'll be hidden by default. To add that description, add that attribute, you just add it in front of the type. Public int foo, that means anything can see that attribute of that, or that property of that object. If I say private, nobody except for internally can they see that attribute within that, or that variable within that class, right? Public has a special use or a special reason to use it when we're talking about Unity, because it's the way that we can also make things visible from our scripts to the Unity editor. So if you want some variables, if you want some data within an object to be editable from the Unity interface, they have to be declared to be public. Right? There's some other things you can do to decorate them that'll make your access of them be, have floating tooltips and having a range or make it a slider and so on. But the important part is this part here. When you say public, it enables it to be seen by the Unity editor. Okay? And once serialized field hit items, but we'll get to those. Yep, don't worry. This is the most important thing up front, though. And the thing to be aware of is once it's visible in the editor and can be edited by the editor, if you change it in the editor, it will also be changed in the code. It may not look like it's changed in the code, but it will be changed within the script. So be careful about having things that are set to a value like this equals 50. Right? If I edited this in the Unity editor, then it would overwrite whatever that 50 is. My script would still say 50, but the editor would be changing it. It's kind of weird. It's in between the instantiating of that object and the actual use of that object. Unity will step in and put the editor's value in there. So be careful with that. All right. Well, I'm running a little bit behind, sorry. C# operators and operations. All right, so we have this typical assignment. We've seen that before. Equals is an assignment. So we have a variable. We want to assign a value to it. And then we have arithmetic operators, which allow us to form basically equations, right? Statements. So things like saying, z should be x plus y, whereas x is initialized as value 5, y is initialized value 10. We want z equals 15, right? So maybe you have a whole bunch of characters and you want to say, as a group, how many HP do they have? Right? So you'd go through each one and add up all their HP using an addition, right? So you have addition operators and some ones that you'd expect to find as well. Subtraction operators, we all know how that sort of thing works. Multiplication operators, division operators, and we have sort of a special one because, division can be special as well, right? Especially in the case of integer-based division, right? If I said 5 divided by 3, and they were integers, 5 divided by 3 would be 1. right? Because I can't say 1 point something as an integer. So division of integers, you have this special behavior you have to be aware of. And to complement that, we have this thing called the modulo operator, or the remainder. So if I said 5, or in this case 16 mod 3, this percentage, it's not take a percentage, 16 mod 3, it gives me the remainder. So it says, okay, 16 divided by 3, okay, that would be 5 remainder 1, right? It would go in 5 times to give me 15, but then I'd have that 1 left over, right? So it's a good way to figure out, how many left over did I have? And that would be useful for all sorts of things like going, iterating through say you want to find groups of 3 or something. You can use the modulo operator to do things like groups of 3, groups of 4, every 5th element, and so on. Oh, that's a great movie. So on. Okay, so you have your assignment and your arithmetic operators, your relational operators, and we're going to start to get fancier now because these are operators that are not just used for creating statements or calculations, but they can also potentially be used in conditionals, right? When you want to make something conditional. That's sort of, conditional within the statement, but also you might have a condition where you said, oh, if this is the condition, if this condition is met, then do this sort of thing, right? That's what we're talking about, conditional execution. We'll talk a little bit in just a second. But typically, relational operators are used to check a relationship between two operands, right? Now our variables, we're going to refer to them as operands. Those are things we are operating on, right? So if the relationship is true, the result will be set to true. So when you have a relational operator, it's going to evaluate to true or false. Is something greater than something else? Is something less than something else? Is something equal to something else? That's going to get you into these logical operations where you have false, true, and so on, right? So is 6 equal to 4? Notice this is a double equals. Otherwise, it would try to do an assignment, right? So we have a double equals for checking equality, different than a single equals. Be careful of that, especially as you start writing if statements and things, because you don't want to do an assignment, you want to do a condition. We have greater than, less than, greater than and equal to, greater than or less than equal to. And also this bang equals, which means not equal to. So if we wanted to say, oh, do this for every month except February, right? We would say month bang equals February. That would say, okay, does not equal February, right? So these are our basic relational operators. Now, just in case that's not enough, you want to do a simple conditional, this greater than that, you can also use our logical operators to sort of combine these things into more complex operations. Or if you just want to say, oh, if this is true and that is true, right? You have these conditions that are based on logical results, on Booleans. Logical operators are used to perform logical operations such as and, or, right? And here's what they look like. This double ampersand and double or double bar here, right? Be careful, single ampersand and single bar are something different. So let's use the doubles, right? So if we had true and true, that's true. True or true, that's true. True or false, think of it, follow along with me here. True or false makes logical sense to say true or false is true, right? Either one of them is true. True and false, something can't be true and false at the same time, so that must always be false. And continue. This is just the flip of that, true and false. And then false and false, yep, both of them are false. This is false or that is false. This is false and that is false. It's not true that they're both false. It's that they are both false, right? False and false is false. All right. So you might use those as part of an assignment or as part of a statement, or part of an actual operation to create some new value, especially the arithmetic operators. But the conditionals and the logical ones, you're also going to be using those as conditional operations or conditional program flow. We're going to use one of our greatest friends, especially in the adventure game, is going to be this if else. There's no then if you're used to languages that had then. We just have if and else, and we're going to start to notice here it's being very explicit about these little curly braces to let us know what the scope of these are. So we have a quick if this, else that. So if, we set a condition here. So maybe the game is saying, all right, 10 turns have passed, so therefore, or 10 turns haven't passed. Once 10 turns have passed, maybe it turns to night. We say, all right, we check this Boolean value. If night, and if night, that means if night is true, right? Just putting it like this way, without any conditional at all, it's just a conditional at all. It just means like, is this true, right? If night is true, it's night. Otherwise, or else, print, what are you worried about? Because it's not night, right? So if it's not night, it must be day. There's nothing to worry about. So the output of this bit of code here would be, what are you worried about? Because, well, night is getting set to false, so it's never night in this little chunk of code here, right? It's always daytime. So before we get into more complex uses of conditionals, there's some other operators worth knowing about that you'll see a lot because, of course, we've heard of C++. There's no sharp operator, but because of C++, we know C++, these single unary operators exist. These are ways to do things like operate on a variable using just a single operation here. So we have what's called the increment and decrement. We can use unary plus and unary minus to do things like negate the sign or leave the sign as is, right? And then we can also use this bang, just like we had not equals. We use this as a logical negation to invert the value of some Boolean or some expression. Right? So we have these unary operators. That means they are just an operator. They don't require two this plus that, right? Two operands. They just take a single operand and manipulate it, like even this not B. There's not B and A. It's just not B. It's just negating E, right? This is decrementing C, incrementing C. They operate on a single operand. For those who want to get fancy, there's also something called a ternary operator, which is sort of an embedded conditional execution where you can say, there's a condition and two expressions. So you can do something fancy there as a shortcut to an if-then-else. We'll leave that. You'll see that. Maybe refer back to here when you see like a condition and a question mark. This question mark is the thing to look out for, right? So when you see this question mark, it means there's a condition, and then subject to that condition, one expression or the other expression will get executed, right? So that's the form of that. I'm going to put this here for completeness, but we're not going to use this for quite a while. Bitwise operations, bitwise operands, where you want to do manipulations of bits, right? This is a much more kind of a lower level operation, useful for masks and patterns and things like that, where you want to twiddle a particular bit inside of a larger variable, or you want to shift bits around and so on. So we'll leave that for now. And you have compound assignments, which are just basically combinations of things like addition plus an assignment. So it'll do all in one sort of thing. So you don't have to say this, instead of saying x equals x plus 5, you could say x plus equals 5. It does the assignment and an addition in one fell swoop, right? So addition, subtraction, multiplication, they all have compound assignments. And don't worry, we're not going to use lambdas. All right. So we have ints, we have floats, we have strings. We can create functions that operate on each of those. We can create statements that use those. We can even use them not exactly interchangeably. Sometimes we have to be careful because sometimes you want, say, maybe to have a string tell the player how many HP they have, for example, right? Or you want to create a string that combines health is and some number, right? So often we can kind of implicitly do type value conversions, right? So we might say string test string equals, and the little set of quotes here, it should just be a normal kind of quote. That just means a blank string plus 5. That will convert this 5. Say, okay, that it is now a string because some part of this was a string. Or you could even do 5 dot toString. So this dot here, see the little dot or period, that means we are invoking a method of that object, right? You may not have realized, but even something as simple as an integer, to some degree, depending on the language, has some methods in here. Like it has an actual conversion method to say how to convert from 5, the integer, to a string. So we're calling the toString method of the object 5. A little fancy, but you may see that. Other times, you're going to be you may be a little bit more explicit as well, referencing, say, the type itself. So if we wanted to use the text true as opposed to the just value true, and it was a string, we might need to parse this string and turn it into a Boolean value. So we would say bool.parse true. Or say you wanted to take a number as a string and turn it into a float. You might say float.parse. Parse means convert or step through it. You know, normally this is with a string. You parse strings like this. But it's all kind of part of conversion. So you may see, a type and parse. That is basically going to be a conversion that you're going to be using. All right. Whew. Now we're at 37, which isn't too bad. Sometimes this forms the next lecture part, but we can, let's see. Let's talk a little bit more and add a little bit. Let's see, we're gonna go, let's do a little bit more of an exercise. We only have 12 minutes. Let's do this more like an exercise. All right. And we'll come back here. So going over to Unity, the easiest way to kind of try things out is we've created this game manager object. I like to create the game manager object and put this script on there just so we have some convenient way to write code and test it out, right? Just to try things out. So I'm going to go ahead, double click on game manager again, and I put whatever I want in here, and this will come in handy as we're trying to do other things. So let's try some code in here. Now, I could say int x equals 5, int y equals 10. And you'll notice, some squiggly lines here. Unnecessary assignment of a value to x. Why is that unnecessary? Well, I'm not doing anything with x or y yet at this point. But now maybe I say print x plus y. Now you notice those squiggly lines went away because I'm using them. And it's also giving me a little squiggly line here saying, well, you're expecting a semicolon. Okay. So I've got x equals 5, y equals 10. Print this. All right, so let's just save that. Come over here. And we'll go ahead. And if there's no messages here about syntax errors, see, okay, nothing changed here. Let's hit clear. We'll hit play. And we'll see, we'll get a whoop sound. And you'll see over here, hello world, and then the number 15, right? So it printed hello world and the number 15. Now, over here in my game manager, what is orange is such a color here. You'll see there's no exposed variables, no exposed methods or properties and so on up here. I really can't get at anything just yet. So let's stop the game from playing and talk a little bit about what we're seeing here. Now, right now, I put these integers, these two integers, they are within this method here, within this little procedure that I've created here, this method, the start method. Now, remember our curly braces here are scope. Anything declared within this scope here actually goes away when the scope closes. So this int x, int y only exist within this method, within this function. They don't exist anywhere outside of that. There's nowhere I can refer to them. They don't even, next time if I call this function again, Ooh, how would I call a function more than once? Well, that's a good one. Well, start, let's see. I'm going to create a new function. I'm going to create this. I'm going to say, oh, it's going to return an integer. And I'm going to call it add int x, int y, now it's complaining here, game manager add, not all code paths return a value, right? I told it here, I said, oh, this is a method that is an int, which means it needs to return a value. So I have to say, oh, return something. And what is it I want to return? I want it to return x plus y. Okay, so now I've created a little method here, and by default that's private, and I'm gonna do this. I'm gonna say add x plus x y. All right. Put a little comment. Maybe I'll call it. I wouldn't get a feature for that, but anyway. All right. So, naming rule violation. Oh, good point. All right. So add x and y. Good enough. So I'm taking those two values. I've created a little function I'm going to call, and I can call this function within that function. Right? I can do that. I could have said, oh, get it further, int z, and don't give it a value there. And instead I'll say z equals add x, y. And since I went to the trouble of doing that, I'll do this, right? So we have x and y and a value z, and z will be x added to y, and I have a little function down here, and it's all good. All right, come back to Unity. And press play, and it should work just exactly as I said before, right? We've got our 15, because that's what x and y are, all good. So I'm going to ask, if I were to do I want to do something fancy here. If I do this twice, for example, the solution will be the same, right? Because x and y actually don't have any, they're just of local scope here. Oh, I know what I want to do. Sorry. I'm going to take these two and put them here. And I'm going to get rid of these. So, all right. So, okay. It's a little bit of a weird add operation because I'm not actually passing it a value, but I wanted to really demonstrate what's happening here where I have this 5 and this 10 that are locally scoped here. And I'll even go so far as to say x equals that. Okay. All right. First off, I want you to guess, what is this going to print out? Anyone? If it works. Oh, it's suggesting I use compound assignment, but anyway. So this should print out at 15. Right? Nothing's changed. Now, what if I were to do this? What would be the solution? There. Oops, sorry. Anyone? Want to guess? Still 15, right? So someone else guess 20? Maybe 25. That's right. Yes, yes. So what's happening here, it is going to be 15 each time because these two, this int x and int y here, are what we'd call local variables. They are only local to this particular method. So every time that method is called, these are going to get reinitialized. So in this class here, we really didn't have any class data at all. We sort of have that x, y, and they're just kind of weird hanging out there. If we really want those to be class data, right, or properties or fields of that class, we define them up here in the scope of that class or outside of the scope of any of those methods. Right. So now this would be quite different because now every time we call add, we would be referring to this x and y. Oh, it's trying to make all kinds of great suggestions. So now each time through here, it will actually change the value and have a lasting impact on it because now we're talking about using class variables or class actual fields and attributes as opposed to local variables. Right? So 25 as the result. Right? See that there? So the important part here is just realizing that within our class, when we define things at this scope out here, meaning that they're not within any particular method, they become class variables. These are methods of this class. Z in this case is a local variable because it's local to this method. Right? It only exists within here. Right? We couldn't say, oh, for example, if I said print Z, it will complain. Whoa, look at that. Because it has no idea what Z is. The name Z does not exist in the current context because Z was something that was local to that function. So if I put this up here, though, now it becomes a class variable, and now it's all good again. Right? So Z exists and life is good. All right. So that's 1150. And we've got through some basics of coding, and now you have a bit of a playground. You know, if you have your game manager and start using, you can use the start functions. Basically, think of start as being your main for this game object. And, you can get a feel for the basic types of programming. You can kind of play around in here. We'll talk about, next time we'll kind of connect things back and forth between the Unity UI elements and what's going to happen in here and how we're really going to start fleshing out our game given this level of kind of decision making and this level of stuff that we're going to do inside of there. Thanks again for your patience with regards to that call I had to take. And if you do have any questions, I'll certainly be happy to make up the time through answering questions on Discord and anywhere like that. And do check see if you have your account active on Perforce and try to get that set up. And that's it for today. And I'll see you all on Friday. Right? Okay. Take care.